I am Muchekwa and I am back with Maths XYZ, and today we will be continuing with trigonometric ratios on reduction formulas. Remember from the lesson that we did yesterday about angles being negative. All angles measured clockwise they're negative, and all angles measured anti-clockwise they are positive. And an angle of theta is only positive in the fourth quadrant, of which is the cos only. And in all this other quadrant, the first, the second and the third one, an angle of theta is negative, not positive. All right, let's look at an example of which we will have angles which are negative in the question. All right, the first example, it's sine negative 180 minus theta multiplied by, all right guys, I think I'll need space, so let me just write small. It's sine negative 180 minus theta multiplied by cos negative 180 plus theta multiplied by tan negative theta minus 1. All right, the space doesn't allow, minus 1 plus cos squared into 100 theta minus 360 degrees. All right, remember with our trigonometric ratios in Cartesian plane, there is no quadrant of which we find negative 180 degrees minus theta. Then with this one, the first thing that we do is to take out a common factor of negative. Then we'll have sine into negative, and then we'll be left with 180 plus theta. All right, and then when it comes to cos, we do the same. We take out a common factor of a negative angle. Then this will be cos into negative, and then we'll have 180 minus theta. All right, and then with tan negative theta, remember a negative angle is only positive in the fourth quadrant. That means for tan it will be multiplied by negative tan theta. It's negative in the third quadrant. All right, minus 1 plus, remember it will be cos, taking out a common factor of a negative, we'll have negative into 360 plus theta. Actually minus theta, guys. It will be 360 minus theta. All right, and then we'll have squared there. We'll have a squared there. All right, and then from here, starting with the first one, sine into a negative angle, it will be negative sine theta. But then we have 180 plus theta, of which we know that 180 plus theta is in the third quadrant, of which at that quadrant only tan is positive. That means that it's negative sine theta. Multiply by this negative from the negative angle, it will make it a positive sine theta. Then we'll have positive sine theta multiplied by 180 minus theta. It's in the second quadrant. All right, and in the second quadrant only sine is positive at that quadrant, but then we have a common factor of a negative, and remember that a negative angle is positive only in the fourth quadrant, of which in the fourth quadrant we only find cos at that quadrant. That means that we have positive cos, and then we have 180 minus theta, which is negative because it's in the second quadrant. That means that we have minus cos, so guys, we have minus cos theta. All right, and then that tan, which is because negative angles are only positive in the fourth quadrant. All right, then it will be negative tan theta, and then minus 1 plus, okay, and then with this one we have 300 cos into a negative angle is still cos, positive cos, and then 360 minus theta is still positive because it's in the fourth quadrant. Then that means that we have squared there, we'll be left with cos squared theta. All right, and then from here what we do, we have sine theta multiplied by tan cos theta multiplied by tan theta plus minus 1 plus cos squared theta. All right, from here let's change tan in terms of sine and cos. Then we'll be left with sine theta multiplied by negative cos theta multiplied by negative sine theta divided by cos theta plus 1 plus cos squared theta. All right, and then this and this will cancel out, and we'll be left with sine theta. Negative and negative will multiply out and it will become positive. Sine theta multiplied by sine theta plus 1 plus cos theta, cos squared theta. Alright, and then from here what we, oh actually it's minus, sorry guys, it's minus 1. From here we have sine theta multiplied by sine theta, of which we know that those two, it will give us sine squared theta. Just grouping out the like terms, it will be sine squared theta plus cos squared theta minus 1. Remember from trigonometric identities, sine squared theta plus cos squared theta is equals to 1. That is from trigonometric identities. Then those will be equals to 1 minus 1, that will give us a 0. That means that our answer for this example is equals to 0. Alright, let's just do a quick recap, guys. We have a negative angle because we have minus 180 minus theta, of which when we are doing a trigonometric ratio on Cartesian plane, there is no quadrant where we find negative 180 minus theta. So what we do, the first step is to take a common factor of a negative, and that means that we will be left with 180 plus theta. And then we check a negative theta is only positive in the fourth quadrant, of which only cos is positive at that quadrant. That means if we have a negative tan of negative theta, the answer is negative tan theta. If we have a sine of negative theta, the answer is negative sine theta. But if we have a cos of negative theta, the answer is positive cos theta. It only becomes positive when we are dealing with cos. But any other trig ratios, the answer is a negative cos or tan or sine of that angle. Alright guys, just always remember that all angles measured anti-clockwise, they're positive, and all angles measured clockwise, they're negative. Alright, let's do another example on trigonometric reduction formulas to see how do we deal with reduction formulas when we have a negative angle. Alright, another example. Okay, we have sine of theta minus 180. We have sine theta minus 180 multiplied by sine into 360 minus theta, and then minus cos, oh guys, space, Alright, let me just write small so that I can make up space. This is sine theta minus 180, and we have sine 360 minus theta, and we have minus cos, this is minus cos 180 minus theta. Alright, and then multiply by cos 360 minus theta. Alright, the first one, which is sine, we take out a common factor of negative and we'll be left with 180 minus theta. Alright, and then when it comes to sine 360 minus theta, 360 minus theta is found in the fourth quadrant, of which at that quadrant only cos is positive. That means that here we have negative sine theta minus cos into 180 minus theta. 180 minus theta is in the quadrant of which at that quadrant only side is positive. That is the second quadrant. That means that we have minus, this will give us a minus multiplied by the negative. There it will give us a plus cos theta. Alright, and then multiply by cos 360 minus theta is positive, since 360 minus theta and cos, they are found in the same quadrant, which is the fourth quadrant. And then this will be cos theta. Alright, and then dealing with the first one, cos of a negative angle is equals to negative sine. I mean sine of a negative angle, it's negative sine. And then 180 minus theta, it's actually positive sine theta. That means that here we'll have negative sine theta because of this negative angle. And then this multiplied by sine theta minus, actually plus cos theta multiplied by cos theta. So this and this will multiply out and we'll be left with sine theta squared, sine squared theta plus cos squared theta, of which we know that sine squared theta plus cos squared theta is an identity, then which is equals to 1. Sine squared theta plus cos squared theta is equals to 1 according to trigonometric identities. Alright guys, I hope you understood this example. Always remember that a tan of a negative angle is equals to negative tan theta. A cos of a negative angle is equals to positive cos theta. And a sine of negative angle is equals to negative sine theta. It only becomes positive when we are dealing with cos. And with any other trigonometric ratios, it's equals to negative. Alright guys, I hope you enjoyed this lesson. If you have any question, please let us know so that we can have a follow-up on it. And don't forget to subscribe to Maths XYZ so that you can get daily notification when we upload videos. Alright guys, thank you.